quay video. Today is my lab engineer get sick, but yeah, he is a very good person. He has a full responsible to come here and make recording of my lectures. Okay. He is one of my students. He studied bachelor program here, and now he becomes lab engineer. He also completes master program at BTU, and in the future he continues to study PhD program. He is very good. So up to now, I have 3 PhD students and over than 10 master students to follow power systems and renewable energies. So we reviewed a little bit the information from last week. We discussed about the relationships between B and F, right? Q and V. Of course, they have a linear relationship, right? And we have this law, SB and SQ. That means here we have F, here we have B, okay, or we say B generator. This is F no loss, this is F rated or full load. Okay, so here this is full load, so this is B rated, right? And we have the curve like this. Okay, or if here we have V, and this one we have QG, generation, reactive power. Okay, so we have V no load, V full load, and of course we have Q rated, right? And we have QV curve like this. In this one we say VF curve. This one is QV curve. Okay? Yeah. So according to the relationship, we have the observation, right? So if we consider right movers, set point. That means we are considering no load frequency, right? No load frequency. Yeah. So when we increase the set point of right mover, that means we increase full load frequencies. So when we increase no load frequencies, that means we increase VG, that is output generate power. Okay? Yes. That's right? Yes. For example, here we have F full load mean system frequency. Okay? So now when we increase F no load, right? We can get this one. Yes? Okay? Yeah. So this is system frequency. So now we get B rated here, right? So this is consistent to the observation, right? When we increase no load frequency, that means we increase generation power. Of course, F systems is constant. We hope. Why? Because for the power system, we only have 2 values of fundamental frequencies. If we follow Russell's, frequencies is 50 Hz. If we follow the USA, the frequencies is 60 Hz. That is the reason the power system in Taiwan has the frequencies of 60 Hz. China is 50 hertz. Yeah. European countries 60 hertz, right? Okay, come back. So now we talk about no loss. Voltage. So if we would like to increase QG, which is generation reactive power, that means we need to increase 5M, right? Because when we increase 5M, that means we increase AI. Do you agree with me? But to increase 5M, we need to increase what? IDC or INDC, a field current. Increase field current. We increase what? We increase rotating rotor magnetic field. That means we increase EA because we have the relationship EA is A proportional to K 5M omega C, right? So when we increase 5M, that means we increase AA. We increase AA, that means we increase QG. Okay? Yeah. So in summary, when we increase IF, we increase QG. Okay. Because we increase, so no loss voltage means AA, right? Right? Because at the open circuit or no load condition, IA is 0, and we already have the formula, right? EA is equal to E V5 plus RA plus JXF times IA. Okay? Sometimes I give offer now, sometimes I use vector, it depends on me. But you should understand, right? This is complex numbers, right? Okay, so if we have no load condition, that means IA is 0, so that means EA upon this is phase, right? EA equal to V phase upon circuit, right? Upon circuit means no load. Do you agree with me? Yeah, so that means when we increase EA, we increase reactive power, otherwise reduce EA by reducing RF. Q rate is reduced. Okay? Yeah. So Friday. Okay, last Friday we discussed about these information, right? Now continue. Now we discuss about apparent power and power factor ratings. Yeah, we need to understand this formula first, right? And I also explain to you. So you should remember, every synchronous generators we need to know rated apparent power. This is the root of 3 VL. Okay, IL or 3 is V phase IA. Okay, yes. But this one is rated. Okay, so V phase is always constant. So here should be the rated voltage. Okay, and it's a rated, so we need to limit IA to becomes max value, maximum value. So we have the condition, right? How IA should be 100 equal to 0 and less than or equal to IA max. Here. Okay? Yeah. This is the idea of rated apparent power and its maximum aperture current. And we shall have the phasor diagram. This is the phasor diagram for different kinds of loss. Okay, here is lagging, here is leading, and here is unity power factors, or this one is IA2 mean resistive load. Okay, so if we observe this phasor diagram, we have three cases. If we consider IA1, this one for leading case. Right? Why? Because IA1 leads with phase. Do you agree with me? Yes. Okay. So when we consider IA2, IA3 here. Sorry, 3 and 4. Okay, so this one is lagging cases. Okay, why? Because IA3, IA4 lag with 5. Okay, this one is lead. Yeah. So we have em chạy xuống phòng 320, xin thầy 4 cục pin 2A, 4 cục pin 2A là pin 2A. Nói gặp chị Linh, xin cho thầy Dương 4 cục pin 2A. Cái này, cái bự này nè. So this is IA2, right? This one is unity power factors, or we say resistive load, right? Because IA2 the same direction with phase. Okay? Yes? Yeah. And for this phasor diagram, we assume RIA is 0. That means we skip armature resistance. Okay, so we can get this diagram, right? This diagram. So for IA1, IA1. Yeah. So we have the phasor diagram. This is V phase. So this is IA1. Okay. Yeah. So because IA is 0, that means IA times IA 0. Okay. So you get this one is JXS IA, right? And here we can get EA1. EA1. What is EA1? Okay. Yeah. So if here is IA max, if here is IA max, that means look at this one is delta, right? We have delta listed in the phase angle between V phase and EN. Okay, yes. So here we get this one is delta, right? Okay. Yes. So if IA max, you get this is max. Okay. So we hold the circle like this. Here. Because this is the circle with the this is radius, right? Radius of this circle. Okay. And then if we have yes, so if we have IA2, this is IA2. Okay. Yes. So And then we can get here is chase XSIA, and you get this one is DA2. Okay, this is delta 1, this is delta 2. Look. If we have IA2 here, so this is DA2, right? Yes. Yes. Now, and we know EA2 should be here because this is the boundary. It is the boundary, right? It is the boundaries about IA max times XS. Okay, right? Right. So then we have, for example, I pick up IA3 for next example, right? This is IA3, okay? So here, then this is perpendicular to this one is IA3, okay? Yeah. So you get IA3 like this. So if this segment over or go out of the boundaries, we have more thermal. Okay. If DA is out of the circle, okay, because this is the limitation of IA max and XS. Okay. Yes. So this one like origin, right? Now we consider this one is y-axis and this one is x-axis. So here I pick up IA3. So this one is delta. Delta is what? Delta E. The phase angle mean? No, you stand up. Stay here. You forgot the rule, right? Or maybe it's the first rule is up to you. Okay. Yeah. Then pay me 100,000 Vietnam đồng because you waste my time. Okay. 45 minutes I get 500,000 Vietnam đồng. So for you 1 minute, give me 100,000. Okay. Okay. So if we have visiting lecturer, you know, 4 professors, 1 academic hour, they get 1.5 million VND. Now I am professor position. So 1 academic hours, I am local lecturer, you know. I only pay, 500,000 VND. So that means I don't need to teach anymore. Just get enough responsibility, and I go outside for teaching. I get more money. Not fair. Do you agree with me? Of course. I just forget it. Because this is about economy, and we go back to academic issues. Okay. Thank you so much. You have a girlfriend? I will introduce to you. Okay? So you need a girlfriend now? Okay, go back. So this is theta, right? This is theta, right? So that means here is theta. So you get this segment A, I1, I3, right? Sine theta. Okay? Sine theta. What is this? Okay, what is this? Because I3 is max. Okay? So we have QE1, Q3 phi A3, V phase, right? I now this is I3 sine theta. Do you agree with me? Okay, V phase is constant. V phase is constant. Okay? And I3 is also constant. So when we decrease 3 phase, you need to decrease sine theta. You decrease 3 phase reactive power, you should decrease sine theta. That's correct? Correct. So that is the reason, you know. So when we decrease I2, that mean we decrease theta, you know. So this is theta 3. Theta 3. How about for theta 4? Maybe I draw theta 4. The 4. So for example here, you know, more theta. So now theta 4, right? Oh, this is stupid because I max, right? Because this A, so we need to consider another circle like this. So maybe here reduce a little bit. Yes, reduce a little bit. Sorry, it is too large. Okay, yes, like this. Okay, so you get here because we have IA max, right? IA max. Okay, so this is IA4. This is IA4. IA4. Okay, so you get here A4, you know. So you get theta 4. So theta 4 is higher than theta 3. So reactive power is increased. Right? Correspondingly. Okay? So now here you get Q4, here you get Q3. Are you with me? Yeah. So we have the conclusion. So this powdering belonging to active power, or we say proportional to active power, and this one proportional to reactive power. Okay. Any questions? Any questions? Any questions? Yeah, any questions? So far so good. So far not good. And fail this course. Yes, okay, continue. Yeah, and here you can see more lacking. And this is EA4. Okay. And yeah, this is the thermal limit of stator widening. This is stator widening. Why? Because this is I mean armature widening or armature current or stator current. This is the thermal limit of stator widening. Now, look. Now, of course, we have the relationship between phasor diagram Okay, for V, for E, for I, blah blah blah. Now, imagine that if we modify this phasor diagram a little bit, we can get VQ phasors. Diagram, okay, VQ phasor diagram. On top you see VG, QG, yeah. So, at the top figure, we just pick up a lacking case. This is IA, this is V phase. Okay, we skip I, so this one is chase XS IA, and then you get EA, right? Right? Yes. And go back to the theory, we also know the direction. The direction of B, right? I mean the flow of B and the direction of Q, right? BG and QG. Okay, so BG is flowing from the lead-in angle, right, to lag-in angle, and QG is flowing from the higher voltage to the lower voltage. Yeah. So look. Here we have positive, negative, DA, right? It's a chase XS. Now we have here it's an EB chase XS, right? Here we have EC chase XS. Yes. Okay, and here we have the lot. Right? This one is V line, or we say V terminal, and this is neutral. So here is V phase. Okay? This is IA. Or here you should change the current for phase A, for phase B, or phase C. Okay? So for example, this one equal to IA. Yes. This is loss, so we have Z, Y. Y mean Y connection of the loss. Okay? That's Y. This A, neutral. Everybody knows the active power flow will flow in this way, right? V from here come to the lot, right? Because this is lot in the generator, so the power is always flow in this way. Do you agree with me? Yes. So look, active power will flow from the leading angle to the lagging angle. So now we consider AA. So that means if we follow active power from the rest of this, AA should be lead V phase. Right? So look here. Now AA is here. V phase here. So that means AA leads V phase. So the power will flow from the leading angle to the lagging angle, right? Right? Okay, so in this case, AA is always leading V phase because the power will flow in the direction. Right? So AA leads V phase, that means delta is positive. Right? That means if here a V phase, AA is always active. bottom. This is bottom. Right? A is always located at the half of surface at the top. Okay? Yes. So if this condition is satisfied, the power flow of active power will follow this direction. Come to the lot. Okay? Now, Q. QG will flow from the higher voltage to the lower voltage. Okay? So that means here is PI, here is V phi. So if Q follow this way, so we should make sure EI should be higher than V phase. You know? Because look, reactive power will from the higher voltage to the lower voltage. So if this one is satisfied, okay, Q flow this way. Now look, if you consider the magnitude of EA, so the magnitude of EA is higher than the magnitude of V phase, right? So this condition occurs if and only if this one is lagging load, right? Lagging load. So if we have EA less than V phase, do you know this case? Yes. So EA less than V phase if this one is leading load, right? Leading load. So leading load means capacitive load. Okay? So Q will come back to the generator if that's why a capacitive load. Okay? Yes? But we don't want to get this situation because if Q is coming back to the generator, we have more and more thermal and boom, goodbye synchronous generator. Is it clear? Yeah. Do you understand? Good. Of course, if we have resistive load, we don't have Q, right? We don't have Q. Now come back this one. So B is positive, Q is positive, right? Why? Because this is lagging. This is lagging load. So the generator will supply B also Q. Okay, so we have Hg now is B plus JQ, right? This generator will supply both B and Q because lagging load. Lagging load. Okay? Is it clear? Yes. Okay, so now look at the bottom diagram. Now I would like to multiply all segment here, all vector here with 3V phase over xs. Why? Look, because if we go back to the theory, we have V out equal to V convert. If R8 is 0, right, equal to what? 3V phi EA over XS times sine delta. Do you remember this formula? You don't know? So we have induced torque like this. 3V phase EA over omega M XS sine delta. Okay? Yes. Of course. Of course. Okay? So, now we have V phase. We have EIA is lagging with theta phase angle. V is not I. So here you get this one is JXS IA, and this one is EA. Okay. Okay. So this one is EA. So this is what? This is delta. Right? This is delta. Delta is the phase angle between EA and B phase. Okay? So now we consider this segment. This EA is a delta, so this one is EA times sine delta. Do you with me? Okay, so I would like to indicate this segment is proportional to B, right? So if I times this one, if I times EA sine delta with 3V phase over XS, I can get here a B 3 phase or B out. Now these phases become BQ phase because we times this segment with 3V phase over XS. Okay, so here we time this segment with 3V phase over XS. Okay, but if we only consider this segment, that's not enough. We need to time 3 phase over XS for all vectors here. Right? Okay, so now we have the new one. This is the new one. This is the new one. Okay, so I draw again. Now consider this one. This one is the V phase, right? V phase times 3V phase over X. So this one becomes 3V phase square over XS. I mean this segment. Do you understand? So maybe it's okay, that's okay. So now we have this one, right? This one. This is IXS, sorry, J's XS IA. So now become J's XS IA V 3V phase over XS. Okay, just times 3V phase over XS. So now we get this curve. This is EA, right? So now we have EA, right? What else? 3V phase over XS. Oh, sorry. Okay. So this is XS. This is XS. Okay, so we can get 3V phase IA. What is this? 3V phase IA as 3 phase. Do you agree with me? So if I say J V phase IA, okay, 3, right? 3 E as 3 phase. And I modify a little bit. I get 3 V phase I new dot. So this one becomes conjugate I ignore J. Do you agree with me? It is the same ZA plus JB. So ZR is A minus J to the conjugate complex numbers. So if A with no A, okay, right? Yeah. So if I is not J, we get IJ over S, right? Okay, that's correct. For example, we have IA is IA with the phase angle minus theta, right? Minus theta. So I can change here. To change here, that means with what? Plus what? Plus 90 degree. Plus 90 degree, right? So we can get IA with 90 minus theta. Okay, so if here is a real, so this is follow for the circle. So if here is this is theta, so this is 90 minus theta somewhere here, right? I should be here. It is theta. Okay. So we get this one. So we need to demonstrate this one become theta. Okay. This one we IA is conjugate. Is that correct? Minus theta is here, right? Minus theta is here. Then this is minus theta. This is minus theta. This is minus theta. Again, here is minus, okay, sine. So 90 is minus theta is here. This is cosine. Anyway, just give it, we demonstrate later. Okay? We will have some problem. Just forget that we come back later. Okay? Yes. Okay, so if we consider the segment, the magnitude, you can get X3 phase, A3 phase, IA. Okay, we just consider the magnitude. Okay, what else? And now, IA, right? Yes. Yes. So now we have IA. The segment, right? IA times 3 V phase over XS. Okay. And this segment, right? This segment is here. 3 V phase over XS times RPA sine delta. Okay? So this one EB, right? This one EB. This one EB. Yes, this one. And what is it? This one is Q. Q. This one is Q. Why? Because here we have the segment IA 3V phase over XN, right? And this is theta. So this one is theta. So you get this segment is what? A 3V phase. 3V phase. 3V phase. IA is over XS. Psi delta. Something wrong. IA So we don't use this segment. We use this segment is better now, right? This segment. So this is theta. So mean this one is theta, right? This is theta. So this one is theta. Because this angle equal to this angle. Okay. So here we get psi delta. How about theta? Psi delta psi theta 3V phase IA is the Q. Do you with me? So this one is just proportional to QG, but this one is QG. Clear? Is it clear? Any questions? This one is 3V phase, right? IA, right? So if we determine this segment, we come with delta, because this one is delta, right? Delta. This is delta, so this one is EA psi delta, right? We come with 3V phase of SS to get this VG. Okay, and look, or this one become what? If we consider theta, so this segment is also 3V phase IA cosine theta. Do you read me? Cosine. This segment over this segment. Okay, so we have two ways. We calculate up to power with the phase angle theta, or up to power with the phase angle of delta. And this one, okay? So now we can see that this is Q. This is Q. And this one is B. Okay? So this one becomes triangle. Triangle, power triangle. Right? Power triangle. Okay? But for here, this is origins. For phasor diagram, this is origins. So if I move the origins from here to here, here to here, here to here, we can get this segment is minus. This segment is minus. Why I need to move the origin here to here? Because this triangle like polyform. Okay, so here is B. right? And here is Q. So B plus Q, you guess S, right? So this is real part. This is imaginary part of S. Okay. A little bit difficult to understand. Normally this one is real part, this is imaginary part. But that's okay. This one for our definition. Okay, we can define here is real part, here is imaginary part, imaginary part. No problem. No problem. Okay. Yeah. And look, yeah, if we follow arrows, this is minus infinite to positive infinite, minus infinite to positive infinite. So Q is positive, B is positive. So that's mean this is the lagging case. Yeah, we assumed before. You know, the lagging case we have PG is positive, PG is positive also. Okay. Is it clear? Any questions? And this is more explanations. Okay, you should read for yourself. Continue. Continue. Now we modify. Oh, here I also explained to you here, right? Minus. Minus, because we move the origin from here to here. So this is minus 3v face square alpha xs. Okay. So this is Q, this is B, this is K bar, kilowatt, okay. Kilobar. Yes. So now, to be adapted with this diagram, we need to modify these formulas a little bit. We have B8, V3, V phase IA cosine theta. Okay, so if we times XS and alpha XN, okay. Okay. The same, you know, the denominators we have xn, numerators we have xs, xs over xs. Okay, so this one equal to this one. Why we need to modify this one? Because we have the proportion of 3v phase xs. So if we modify this one a little bit, you know, the same. The same. So here, 3v phase xs times this one, 3 we face xn and this one for B, but for Q. You understand? Okay, continue. Continue. The origins of phasor diagrams is here. Is here. So for phasor diagram, this is minus V phase, V phi or V phase. So here, this point now become minus 3v phase square alpha xs. OXS. Now Q. Yeah, so again, the origins on the power diagram is here. Okay, this is the origin, so for here to get the point of minus 3v. So now we have this segment. This segment we say DE. The DE is the length corresponding to A on the power diagram. This is phasor diagram. This is power diagram. And we have the radius of the circle, right? Of the circle. And the radius of this circle is
DE to be 3V phase EA over XS. Very easy to recognize that. Here. So how about Q? So we have Q is 3V phase IA, right? And it is psi delta and V, we have 3V phase IA cosine delta. Or V is equal to this one, right? 3V phase IA over XS sine delta. So you get V max. V max that means delta is 0. Okay. So you can get V max is 3V phase EA over XS. Over X. Of course, this one the magnitude. Yes. And the maximum powers is S, right? S. Because S is what? S is B squared plus Q squared. So you get V max if Q is 0. Okay, because delta is 90 degrees. If delta is 90 degrees, that means theta is 90 degrees also, right? Oh, theta is 0 and delta is 90 degrees, like this. Okay. So if theta is 0 degrees, means IA is the separation between phase. Okay, then the resistance loss. So Q is 0 and V max you can guess S. Okay? Or you can modify a little bit. Okay, SA 3 phase over IA, right? So if we modify 3 is V phase and IA is V phase over XS. EA of XS. IA is EA of XS. Any questions? Sure, continue. Look. Why we get this one? Because, and we mentioned before, normally here is V, here is Q. But when we consider this power triangle, here is Q, here B, right? So we need to rotate 90 degrees. You need to rotate how many? 90 degrees. Counterclockwise direction. Why? Why? Because now we would like to get this one, so Q should be here. So when we rotate 90 degrees, follow counterclockwise direction, so that means we rotate this power diagram 90 degrees. You get this one? Okay, so now we make sure here is Q. So if here is Q, 90 degrees. Okay, so here is Q, here is B. Okay, for middle one.
Look. Okay.
So now here we modify. So now I don't want to use here is V, so I modify here is V. Okay, that's okay. No problem. So now we skip this one. We say here is V kilowatt. Why? Because the power is always positive. Always positive. So and then in the same direction with the x-axis. So I modify a little bit so the V in kilowatt. Then here is Q, right? Maybe here is a kilobar, and this one is V kilowatts. So this origin here, so now become this one, the same, 0. Yeah. So this point, how many? Minus 3 V phase square of xs of dA, right? Okay, this point minus 3 V phase square over xs. Did you read it to me? Rotate 90 degrees in the counterclockwise direction. It is the last point, right? Okay. So here, so you get this one. This one is dA. dA is what? D 3 dAV phase over xs. Okay? What is this? This one equal to S. Right? Okay? So we can draw the circle now like this. This is radius. This circle. Okay. This one is not S. This one is just the S. Not S. So this one is wrong. This one is wrong. This one is dA. Sorry. This one is dA. Okay? Yeah, my mistake. dA. Okay. So look at this this circle. Why we consider this circle? Because this circle will have dA and dA equal to 3 V phase dA over xs. You know, V phase is constant. Xs is constant. Okay. So we only have the variable dA. Okay. So if dA is increase, that means we need to increase phi m, right? When we increase phi m, we need to increase IDC, right? IDC means Im, or we say this is rotor current. Did you read me? Yes. Okay. So of course we can increase Im, but this is IF, this is VR, rotor magnetic field, and you get this direction. This is saturation curve. So when we continue to increase IF, you get VR, VR radius. Okay, and then we continue to increase IF. You go to the saturation zone. Okay, so we need to limit AI. Okay, so if we have IF max, you get A max. So this is the limit of rotor current or field current. Do you agree with me? This curve, right? V phase is always constant, XS is constant. So I change if IF change, so we continue to increase IF. After some values, you get AA max. You need to stop. Okay, so these boundaries is for the limitation of rotor current. Okay, so why? Because if we continue to increase IF, VR will not increase anymore, and we have more thermal because we increase current. Okay, and you get more temperatures, more thermal, and then rotor winding will be burned out. So this is the limitation of rotor current. Okay, now we have another circle. I'll make a little bit. Okay. We talk about this curve, this circle. This is S, this is N, right? This is origin, so this is S. Okay. So for here you get S. S here. This is S. If we have S, here is V, and here is maybe a little bit higher. Here. A Q. I assume here is X max. So you get another circle like this. Another circle like this. Then yes. Not good, but of course you must understand it is another circle. Okay. So what is this circle? So we have S is what? SA 3 phase IA, So if we have IA max, you get SA radius, so S max, right? Right? So when we increase IA, that means we increase stator current. I mean stator current. Stator current, right? So we have this curve. So this curve is the limit of what? Of stator current. Because V phase is constant. V phase is constant, so we increase IA, that means we increase stator current, and S will be increased. After some time, you hit the maximum, so the boundary is for limit of stator current. This curve. Okay? Okay. So now we talk about another curve. Now we mentioned about this V rated. Okay, Q rated. Now we talk about right mover. Right mover the capability. You know? Yeah. So if we have the power flow diagram of synchronous generator, this is V in, this is V out, right? And the input power of synchronous generator is equal to the power of right mover. It is based on the capability of right mover like water turbine, steam turbine, wind, gas turbine. You know, V in should have the limitation. You know. So that is the reasons we have. For example, here is the maximum input power. The maximum input power of synchronous generator, because when we increase the power of right mover, that means we increase the power of synchronous generator. So now we have the limitation of right mover capability. So if you need more input, more output power, we need to control the dam, to control the water flow volume, right? Yeah. So but we cannot increase the volume of water flow of water turbines as much as possible, because we have a limitation. The limitation of water turbine means the capability of right mover. Okay, so now we have three curves, right? The curve of limit of rotor current, the curve of limit of stator current, and the curve of limit of right mover. So if we combine three curves together, you can get this one. Of course, we need to read this description. Okay, so if I combine, I can combine three curves together. Look at the limit of right mover power. Okay, so if I combine, I can get this one. This is curve one, right? One come here, and then actually maybe I move this one a little bit. Okay. Move this curve a little bit. Maybe it's here. Yes. Okay. So this is curve one. This one is curve two. Right, and this one is curve three. Then this one. Okay. So we combine curve one, curve two, curve three back. Okay. So this one we say the limit of synchronous generator ratings. Okay. Or we say power diagram capability. Or we say power diagram capability of synchronous generators. Yes. We need limit. Okay. Now, description. Now you have 5 minutes. Read this description and combine with my lectures, my explanation here. Try to fully understand. Otherwise, ask me and explain. Again, 5 minutes now, please. maybe you shouldn't confuse this one with reactive power. Okay, so that means this one just the void and the Q axis, right? Here, right? This void is the reactive power void. That means this void is located in the Q axis. Okay. Of course, okay, this is minus. Because here is negative of Q axis. Okay. Yes. Any questions? No questions? We have example. Number 8. One student comes here and summarize these questions. Again, I ask you to summarize, not skip the words and just write the number. No, this is not summary, okay? Nghĩa? Now, your turn. Come here. Try to avoid mistakes again. Okay? Please don't do the mistakes. Okay, similar to last week. Come on, quickly. You can do it now. Come on. Don't worry. Yeah, look this slide. We have some information. Come on. And now, practice, please. Okay, so this is example 8. We have we have the object. That is synchronous generators. You know, I need to mention the objects synchronous generator. You know, sometimes we have generator, sometimes we have motor. And if we have the final exam question, we don't know what the object is, you know, very stupid. You know, every machine we have generator and motors, very different. For generators, input is input in mechanical power, output is electrical power. For motors, input is electrical power and output is mechanical power. And you don't know the objects, oh my god. Okay, so if you find your girlfriend, you should make sure your girlfriend is originally female. Originally, you know. How can we know? Go to the hospital, check the medical report. Maybe you lie another style. But anyway, we need to make sure we have the objects. Okay. Y connected. 6 poles. So we have 3 poles where it needs to be. Why I say original, you know, because we have gain X, we have gain Y. Right? How boy? This is original X and Y. We combine together, you get male. Do you relate to me? And if X and X, you get female. Do you agree with me? This is original. You study biology at high school. Okay? You check it with these. You can know XX and XY. Very simple. Okay. Yes, give it. You have X0. This is Y. XO. Yeah. Right? You have brain XOY. Okay, come back. What else? We have Y connected. Okay? And remember that this is 3 phase, so this is line voltage. So this is only RMS values, so you need to use absolute. You know absolute. And now because Y connected, so VL equal to 3 field of 3V phase, right? Yeah. So we need to calculate V phase directly from this information, right? We have 480 hours the root of 3. How many? Sorry? 2, 7, 7. Wow. Okay. What else? The frequency is 50 Hz. They give us the information of apparent powers. So this is S rated. Output is a 3 phase. Because we have 3 phases of the generator, we have 0.8 power factor ligation. That means theta how many please? Of course, theta is the phase angle between V phase and IA. How many please? Come on. 36.8, right? Okay. Yes. B supply. What does it mean? B supply. This has a synchronous reactance of 1.0 phase. Here, X1, XS. Okay. I assume this generator is connected to the steam turbine. Okay. Capable of supplying up to 45 kilowatts. So this is the maximum input power of chips, right? Okay, the maximum input powers. Yeah, because this power come from right mover, like steam turbine. Okay, so this is B in max. B in max of generator is 45 kilowatts. Okay. Friction release 1.4 kilowatt and core losses 1 kilowatt. Okay, that's on. So now answer this question. Sketch the capability curve of this generator, including right mover power limit. Look, this one is the right mover power limit, 45 kilowatts. Okay. So how can we get the answer? Now we refer this one. Yeah. So that means we need to calculate this one. So if we know this boy, we can draw this circle. If we know S max or S greatest, we draw another circle. And we also know the limit of right mover power, so we can draw the first curve, right? We combine, you can get power capability limit of synchronous generator. That's all. Okay, so very easy for question A. So the first step we need to calculate cuboid is minus 3 phase squares over XS. So be careful, you know, if you use V line, you stupid. You are stupid. Okay? So remember to modify, to calculate V line to V phase. Okay. Yeah, so we can guess minus 3. How many? 277 square over XS and S how many? 0.1. And we can get how many? Look here. Minus 230 kvar. So now we have here this is Q and this one is P. Okay, this is kvar. This is kilowatt. So you can get here, cuboid here, this is minus 230 kvar. Do you agree with me? So to draw the circle, we need to calculate what? D is the radius of the circle. So this is what? 3 V phase. What else? A over XS. Where is D? Here is D. Do we know V phase? Yes, of course. Do we know XS? Yes, of course. But we don't know EA. So, very lucky because they give us the information of synchronous generators and power factor lagging. So, we have EA is V phase plus RA plus JXN times IA. Okay. Okay. Do you have information of IA? No. No. Okay. So that means I0. 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 So we can get it as V phase here 277, and we know the phase angle of V phase is 0 degree. Okay. Plus J, I ignore RA, so you get J 0.1. How about RA? Sorry, IA. Do we know IA? Yes, we know IA because they give us the information of F-rated three-phase. So we have IA, the magnitude of IA is what? Is S three-phase over 3 V-phase. Do you read me? S a 3 V-phase IA, so IA is S three-phase over 3-phase. Okay, so you get 50,000 VA over 3 times 277. How many please? Huh? Sorry? 60 ms. So that means here we have 60 with the phase angle. How many? Look, this is lagging. So this one should be minus 36.8 degree. Do you agree with me? Any mistake? Yeah, we have mistake. Next phase. Yeah. You haven't passed class 1. Why you enter this university? Because you haven't passed class 1. Primary school, we have class 1 to class 5, and you haven't passed class 1. You get what? 1.0, and now, you challenge me, Oh my God. Do you like to challenge me? I will challenge you for final exam. Oh my God. I am curious now. How can you pass primary school? Yeah. Mix up again. And now please help me, how many? How many vertices and right angle? We hope we get the same values in this slide. We have 317.4 with the phase angle up, no point. Okay, with the phase angle 8.7. That's correct? So when you use a calculator, you need to take one more bracket here. Otherwise, you get the wrong answer. You take this one bracket plus the whole. Okay, yeah. So now. We come back to calculate. You get 3 V phase how many? 277, and then EIA 317 over 1.0 Oh my god, this one is 1.0. Hey. And how many please? And we can get 263 kVAR. Okay. So look, for DE you get 263, and Q point you get minus 230. Okay, so this one is the radius, you know. So this one we already, this is 0, so this one you already get 230. So if here we get 33. Okay, so this is DE, right? Right? Now here you already read from our origin to Q point is minus 230. And the radius is 263. So just you need 33 more. Okay, so get DE. So you can get the curve like this. The curve. Yes. With the lectures and this. Okay. Just like this. Okay. So what is this? This is limit of rotor current. Rotor current. Okay. Now we calculate S. We calculate. Oh, S we already have 50 kVA. So this is 33. So here maybe 33 and 50 somewhere here, you know. So this one is S. So you can draw the curve of S like this. Okay, this is S. And SE, S3 phase E, 50 kVA. This is number 2. Limit of stator current. Okay, and we have limit of right mover power is 45 kilowatts. So this is 33, this is 50, right? So for 45 somewhere here. Yeah, this is 45 kilowatt. And now we combine limit of rotor current, limit of stator current, limit of right mover power. You can get the curve like this. Here, right here, and then follow the curve 2, then follow this one, then back to here. So this one is the power limit of synchronous generators. The power capability limit of synchronous generator. That's all. That's all. Do you understand? So if we have any points or any operating point outside of this area, very dangerous because synchronous generators will be broken. Okay, any operating point should be inside this area. How about another surface? For example, here. Why we only consider in this region, in this area, why we don't consider here? Here we also have limit, right? So why we don't consider this one? Why? Why we only consider the first quadrant and the fourth quadrant? Why we don't consider the second and the third? No. Why? Who knows? 2% extra points. Why we don't consider this one?
Because
Yes, because active power is always positive, come from the generators to the load. Okay, this one it means in negative. So limit if we use this one. So that's the reason we only consider this one 2% extra points for you. Comment. Okay, can you give the comment on the Virginia Moodle? We have the Moodle platform of this course. Or maybe let me know your name. Okay. What's your name? Lương Minh. Bình. Các bạn tên Bình không? Bình. Right here. Right? Mày trở lại hay nói trở lại? Ai trở lại? Mày trở lại hả?
Cả hai.
Cả hai hả? Vậy mỗi thằng 1%. Okay, you get 1% extra point for each. Okay? Like, check rec please. 10 minutes. Okay, continue. So, question B. Question B. The question is whether this generator can supply a line current of 56 ampere at 0.7 power factor lagging. Why and why not? Okay, so for question B, we have another lot, right? So at the beginning, we have lagging lot. Lagging lot with 0.8 power factor. So that means theta is 37 degree and IA how many? 60 ampere, right? Now we have another lot, of course also lagging lot. This is question B. But now we have 0.7 power factor and IA new how many? 56 ampere. Okay. Now look at this power capability limits. We have three parameters you need to consider. BQS, right? BQS. So if we go back to power capability limit of synchronous generator S rated how many? 50 kVA. Okay? And Q. B and Q follow the curve, right? The limit curve. Limit curve. Look, so if we have B, if you have B here, B1, we can get Q1, right? You're with me? If you have B1, you get Q1. This is a limit curve. If we have B2, you can get Q2, blah, 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 blah. Blah, blah, blah. But we know Qmax. This is 230 and this is 263, so Qmax is 33. Okay, so follow the power capability limits, you can get Qmax how many? How many? 33 kW. And B max how many? 45 kilowatts. Right? If we follow this one, this is the max, Q max. Right? This is Q max, this is B max. This is minus Q max, right? But we don't care about this one because lagging B is positive, Q is positive. Lead in B is positive, Q is negative. So or we say this one is for lagging, this one for leading. Right? Right? Yeah, lagging. So we just focus on this one, the first current, because lagging cases. Okay, so now, yes. Yeah, now they give us 0.8 power factor and IA. Of course, we need to calculate how many B new and Q new, right? And after that, we double check the new values of power with the power capability limit. Okay, if any point outside of the limit, that means we cannot operate. Otherwise, yes. Okay, so B new is what? V phase constant, right? 277 volt. Okay, so here you get 3 times V phase, that means 277 times IIA 56 and cosine how many? Cosine theta is 0.7. You can get B. How about Q? 3 times 277 times 56, and this is sine. So you can calculate theta new. Okay, and then you can calculate sine theta new. Right? After that, you put here. You can get how many B new and Q new. Now, please quickly calculate it. Now, please come on. Q theta new how many? 45 boy. Come on. Huh? Theta new how many?
45.6.
0.6 and sine theta new how many? Come on. When I ask you to calculate, you need to do it. Don't waste your time. Not kidding. A little bit angry, okay?
0.7.
You waste your time to other students.
0.71.
You study, not my study. So if you waste your time, I don't have enough time to give you more answers, more explanation because you have a lot of homework. You understand? Not kidding. Pay attention to my speaking. Not kidding. Okay? Go back, please. Seven. Now, come on. B new, Q new. B new, how many?
32.6.
That means 32 kilowatt. How about Q new? 23? 33? Boy what? Boy 2. Okay? Yes. Why I ask you boy 2? Because Q max is 33. Fully 33. But when we calculate Q new now becomes 33.2. Even though B new. To B new less than B max. That's okay. But look, this one higher than Q max. Right? So that means we cannot operate the synchronous generator with that kind of lacking loss. Okay? Yeah, and we hope I'm correct. Yes, look. Okay? So yeah, this voice is not a self-operating condition because the operation voice outside of the power capability limit. This is 33.2. Okay? And here just 33. Okay? Yeah. I emphasize, right? Any operating point outside of this boundary is not self, is stability. Okay. Hãy chửi mấy đứa mới được. Không nghĩa mai mới được. Các em biết là cái văn hóa mà đổ thừa người Việt Nam mình gặp phải rất là nhiều lần. Sorry, I miss Vietnamese. Mày không tính thì tao không tính. Tao không tính thì những đứa khác cũng tính. Thấy không? Hiểu không ạ? Và nếu các bạn muốn thành công trong tương lai, không thể nào dùng văn hóa đổ thừa. Hiểu không? Ê, kệ mẹ nó, tao ngồi đó tôi chơi, mày không tính thằng khác không tính. Hiểu không ạ? No. Ngoài việc thầy cho mấy đứa kiến thức, thầy sẽ cho mấy đứa văn hóa, cách ứng xử. Hiểu biết nói không ạ? Chúng ta học để trở thành người có đạo đức, có trí tuệ.
Chúng ta không có đồng đẩy trách nhiệm lên người khác được. Hiểu ý là không? Và thầy muốn lớp của thầy phải có trách nhiệm như thế. Kêu tính đi, thằng này tính, thằng kia tính, vậy ai tính? Tao tính à? Hiểu ý là không ạ? Mình là những con người thông minh, lịch sự, tử tế, không thể làm như thế được. Ok? Ngay cả mình mà mình còn không có trách nhiệm với bản thân mình thì lo cho ai? Hiểu không ạ? Mày hiểu không? Ok. Nhớ là gì? Tài năng là một chuyện, đạo đức là một chuyện. Ok? I just mentioned Vietnamese students. Even though you are very talented, you are intelligent, but you should have it. I cannot use hand calculator to calculate for you. Okay? You come to the class, you have calculator, you need to calculate for yourself. You are talented, of course, but you should have a good behavior. It's my class, no lazy. Okay? Otherwise, go out. How many points you need? I give you 1.0, no problem with me. I cannot get any money from you. Okay? If you give me $1 to buy this coin, no, maybe $1 billion, I think everything. Okay. But you know, is it clear? Sorry Vietnamese, tại sao thầy dạy mấy đứa như vậy? Mấy đứa ra bên ngoài, mấy đứa thấy một cái người nào đó té xe thế này, tao không đợi nó lên, thằng khác đợi. Thấy không ạ? Từ một cái việc nhỏ trong lúc học mấy đứa thấy không? Ôi mày không đỡ, thằng khác đợi, người khác cũng đợi, hiểu không ạ? Thấy không? Hợp lý không? Cái văn hóa này được đổi thừa, được nhường trách nhiệm cho người khác, thấy nguy hiểm không? Ồ, thế thằng đó bị quýnh gì đó. Ôi, chứ sao gì cũng có thằng gọi công an, tao gọi thằng gọi. Vô đạo đức. Why I give you the lesson like this? So if you go outside, you see someone ride a motorbike and he or she suddenly fall down. And you think, oh, I don't need to call the police because another people will call the police. You know, not good. Like this. Oh, I don't want to calculate this one because some student, other student will help me to calculate. You know, not good. Responsibility is not good. You think about university environment and social environment. Not kidding. Do you understand? You have the teamwork. And you think about, oh, if I don't do that, other team members will do that. Oh my God.
Similar in this case. Okay? So question C. What is the maximum amount of reactive power this generator can produce? Of course, okay, we can produce Qg must be equal to Qg max. And you get how many? 33 kW. Okay? kW. So if I would like to keep 56 ampere, I need to modify power factors to make sure we can operate with this load. Okay, so now, okay, modify theta nu. Okay, so now we have Q nu equal to Q max, right? Equal to what? Of course, Q max is 33. Equal to what? Equal to 3 times 277 times 56 times sine theta nu, maybe over comma. Right? 33 kW means 33,000 watt. Okay? And yeah, we also give the magnitude. That's the 56. Okay? But now we need to modify theta. How many? Now, come on. Of course, we need to increase the power factor, right? But I don't know how many. Or we calculate both sides theta nu over comma. How many? 45.1. And here, but maybe 22, right? Yeah, I guess, right? Okay, yes, okay. Yeah, so we just adjust a little bit phase angle. Okay, you can let the operation point, okay, come to this region. Okay, come to this region. Yeah. Okay, this is subscription C. You know? Yeah. Yeah. Subscription D. Hai chữ nó mệt không đây? Chữ mệt quá. Là sao đừng chọc cái chữ nó mệt? Xong ta tới sớm, sợ bị tăng huyết áp. Mà không chữ được. Mà cẩn thận nha, bên sau này mấy đứa lớn rồi cái thầy có con mà cho nó nhiễm với văn hóa đổ thừa nó là chết liền. Thầy đâu có, con thầy ai làm là phải chịu trách nhiệm liền. Thầy phân ra, ví dụ như làm chuyện nhỏ thì bị quất một cây, làm chuyện lớn quất 2 cây 3 cây, thằng lớn thì bị hoài. Ai làm này sai này là biết rằng nó sẽ bị đòn, tập gì mới được. Còn không thôi là sao? Ví dụ này, văn hóa đổ thừa này, nó thấm nhuần trong đầu của những người Việt Nam này, người cha mẹ Việt Nam mình thấy con mình có cục đá đó, con mình chấp cục đá là té, chết cục đá nha, tại cục đá nha, chết cục đá nha, thấy đổ thừa không? Hiểu không ạ? Có thầy không có chuyện đó, không giờ con té là tại con nhìn không thấy đường, con dấp con té, hiểu không? Tại ngu, đúng không? Nếu con đi cẩn thận hơn, con nhìn đường hơn thì con đã thấy cục đá đó rồi, thậm chí hành động cao đẹp hơn là gì? Nắm cục đá đó, bỏ vô đề. Đúng không ạ? Sau này mấy đứa lớn chú đứa có kinh nghiệm, đứa nhớ ha. Sau này làm ba làm mẹ đừng dạy con như thế à, Tư. Mấy con nhà giàu như vậy. Okay. I tell Vietnamese student a story. Okay. We have a baby, and this is parent. Maybe it's in European countries different, but in Vietnam, you know, this is father, this is mother, and the baby is running on the street, and we have a rock, and the baby touches the rock and fall down. The parents say because of the rock, the baby is fall down. No. Okay, because this baby. This observe the rock. Okay, maybe this baby is not concentrated to the rock. Okay, the baby observes something else. Okay, so the father or the mother should teach the baby. He fall down because he didn't observe the rock, not because of the rock. Okay, like this issue I mentioned before. Okay, yeah. Come back. According to the maximum capacity limits, if the generator supply 30 kilowatt of real power, now, you know, the generator only supply 30 kilowatts. VG now 30 kilowatt. Of course, this one itself, because VG max how many? 45, and VG now only 30 kilowatt. That's okay. What's the maximum amount of real power that can be simultaneously supplied? So we have two ways. So if we use power capability limit curve to get how many? Okay, for example, here is 30, and then come here, back here. So maybe you get some values of Q here, right? But this voice is inside this area. Okay, so I get QG is 31.5. I just guess because this one is not really accurate. Okay, so now you can double check. 40. Okay. So this one just help you review. First of all, you draw this curve and then draw this curve. This is maximum right mover power, and then you can get this one. Okay? Yeah. So now if we have 30, and then Q is how many? 31.5 kW. Okay? So this one also less than Q max. So self. This is the first way. The second way, how can we calculate the second way? The second way, we know IA how many? We don't know. We don't know. And the phase angle theta how many? We don't know. Okay, so we have VG now in 3 V phase IA or cosine theta. Okay, so we don't know this one. We don't know this one. So at least we should have the information for IA. You can calculate the QGs. But now we don't have IA, so just skip it. Just skip it. Okay. Yeah, we just use the power capability limit curve. Then we get a value of QG. Okay? Yeah. For example, this one, you know, they give us the information of electron IIs and power factors. Okay, so we finish example 8. This one for your reference. Okay, so summary. Yeah. Ready, please. 1, 2, 3. 1 minute.
chữ mệt quá. Ba, xin bảo hả? Chữ mệt quá bên này. À, mày không muốn cho chồng, không muốn cho thầy vui gì trơn, thầy không kể chuyện vui gì trơn. Chữ mệt quá Phương Anh ơi. Chữ cái đã mà. Nè. Nếu đã là đàn gãy tay gì? Đúng rồi, nó bị vuông nữa đó. Coi không, ngày mai là tôi nghĩ một trò không. Bây giờ tôi bỏ học cái ăn nỉ đi học. Uống chửi rồi. Đừng chửi vài câu nghe mệt. Quá rồi. Dạ cả rồi nữa không thầy nó sớm quá. Hả? Hiểu không? Bây giờ thầy Okay, continue. Next. Summary number 2. 1 minute. Chỉ là bài môn nữa, dụ thì chữ. Kinh khủng. Okay, so we finished the lecture. Now we have some homework, and of course, I will answer to you some of them, not all. Okay, not all. So maybe I okay. So now 11:48. So maybe I choose. Maybe we come back to lecture 2, part 1. Okay. You know, just some question, not on, because this is your homework. Okay. So maybe I answer the homework of lecture 2, part 1, and homework number 1. Number 1, problem number 1, lecture 2, part 1. Look, here they give us the objects of 3-phase Y kinetics, right? Synchronous generator. Okay, and they give us the line voltage, how many? 13.8 kV. And at 3-phase, how many? 50 MVA, and the power factors is 0.9. Please help me. How about theta? This is lagging. Right, come on. Theta how many? So when we summarize the questions, if you know some information, please calculate some parameters correspond to the information.
25.8.
25.8 degree. Good. Stop. Rồi, học được bài học rồi đó. Thấy chưa? Good. The frequencies FSA is 60 Hz. Okay, 4 poles. So that means we have 2 whole pairs. Two whole pairs. We have synchronous reactance, that means Xs 0.5 ohm. Okay, and armature resistance, you get 0.2 ohm. Okay, this is Y connection, so we calculate we phase how many? 13.8 divided by square root of 3. I guess 7.9. 7.7.
7.96.
7.97 kV. Okay. What else? Oh, we have friction and windage. Okay. We have friction and windage loss. How many? We have 1 megawatt, and we have delta B core. That means core losses. How many? 1.5 megawatt. Okay, so the field current has a DC voltage of 120 volt. So we have VDC, or sometimes we say VF, 120 volt. And the maximum of field current IF is 10 amperes. Okay, yeah. So the current of the field circuit is adjustable to range from 0 to 10 amperes. So that means IF is 0 at the minimum and maximum is 10 ampere. So here is the field current. This open circuit voltage, the minimum of field current 0 and maximum of field current is 10 amperes. Okay, so of course this is open circuit. So here this is line voltage, line open circuit. So based on the curve, so remember this is VL open circuit. Open circuit, okay, line open circuit. Okay, or this is EL. Line voltage, and this is IF from 0 to 10 amperes. That is okay. Yes. Remember that this is line. Okay, this is line voltage, line open circuit voltage. Okay, questions. Right. How much field current is required to make the terminal voltage equal to 13.8 kV? So terminal does mean V line, right? V line is 13.8 kilovolt. When the generator is running at no loss, so IA 0, so that means this one equal to. So we have V line open circuit, right? No loss with open circuit. Okay, equal to what? V line equal to 13.8 kV. So if we use the curve, you can get IF how many? How many?
3.5.
13.3, so nearly 3.5 amperes. Okay, yeah. Subscription A. Now we think about subscription B. And here we have the answer. Let me double check. And we have 3.5 amperes. Yes, good. Continue. Subscription B. What is the terminal? What is the internal? So the internal generated voltage EA. So that the S to calculate EA. How many internal generated voltage of this machine at rated condition? Rated condition means full load. Rated condition means full load. And here is full load. Right? Here is full load. So remember that rated condition mean full load. Full load. So we need to calculate IA and the phase angle. Can we guess IAs? Yes, because we have the information of parent powers, we have information of phase voltage. So we have IAs is what? A at 3 phase over 3 V phase. And here you get how many? 50 MVA, that means 10 to the power of 6, right? Divided by 3 V phase how many? 97.97 kV, that means times 10 to the power of 3. You get how many, please?
2,1 kilowatt.
3,002.
2.1
Hmm?
2.1 kilowatt.
2.1 kiloamp.
2.1
Kiloamp.
kiloamp. Okay, yeah, 2.1 kiloamp. Yes. Okay, so we can calculate EA, right? So EA is V phi plus RA plus JXS times IA. Okay, so V phi is how many? 7.97. Okay, that means 7,970 with 0 degree plus RA I 0.2 JXS, that means J 2.5 times IA 2.1, that means 2,100 with the phase angle. This is lagging, so you get here is minus 25.8. Okay, and how many, please? How about magnitude and phase angles? Volt. It's in volt, right? It's amperes, so you get the units of is volt. You get how many? We get 11,544 with 23.1. One. Double check. That correct? Right? Okay, that means, for example, here for AC, I say it's 11.6 with 23.1 kV. Okay? Yeah. Now we know EA. Oh, finish. That's question B. Okay? Because this is question what's in the internal general voltage. So that's question C. What's the phase voltage? V phase. If these generators at rated conditions. Very easy to know. We already calculated before, right? V phase how many? 7.97 kV. Okay, just 5 seconds. You get the answer. Because you calculated before, based on the information of questions. Okay, you know, for the final exam, every such question you get 5%. Okay, so now you get 50%. You know, very easy. I just spend 10 minutes, we get 50%. For homework, you get maybe 5%. So now you get 20%. Okay, very easy to pass this course if you understand the information of the questions, right? So, that's question D. Oh, right? So, that's question D. How much field current is required to make the terminal voltage VT equal to 13.8 kV when the generator is running at the rated condition. They ask us to calculate field current in such a way that terminal voltage is 13.8. Okay, so if we terminal E 13.8, that means we phase E 7.97 kV. Okay, and if we would like to use this curve, you need to calculate E, right? And now here you get EA how many? Remember EA that means phase, right? Internal phase voltage. But this one is what? Line voltage. Okay, so EA we already calculate from here, right? 11.6 with this is magnitude, so we ignore the phase angle kV. So we need to calculate line voltage EL, right? EL how many? Because we have Y connection. So we need to take 11.6 times 0.3. Please, how many? 20.1 kV. After that, we use the curve. So if we have 20.1, we can get IF how many? Do you understand? Remember, this one is always open circuit line voltage or EL, not EA. It's a phase, internal phase voltage. You need to consider Y connection or delta connection. You can get. So for the final exam, I just modify Y become deltas. Oh my gosh. Some students and then fail this course. You know, so again and again, please read carefully the information of the question. You know? Yeah, and I always ask you to summarize step by step information by information. Okay? Yeah, during my class, I emphasize this one many times, but I don't know. You fail this class. Oh my gosh, because now, yeah, you know. Okay, and then, how many? We use the curve, and for the answer you get 10, right? So you get 10 amperes. Because this is 20, you get 10 amperes. Do you repeat me? So, subscription E. Oh my God, how many subscriptions? Okay, so suppose that this generator is running at the rated condition. Then the loss is removed without changing the field current. You know, from subscription D, now I have how many? 10 amperes. Okay, so for subscription E, we suddenly remove the loss. Oh my God. You know, we have more field current, but we suddenly remove the loss. What would be the terminal voltage generator? So when we remove the loss, that means now I become 0, but we keep IL. That means we keep EL, right? So now EL is V line open circuit, right? Equal to 20.1 kV. Or you can